Mr. Hong here with a new video, and today we're going to be talking about transformations of exponential functions. So you will be able to determine the effects of the transformations of the exponential parent function f of x is equal to 2 to the power of x, and f of x is equal to the e to the power of x. And a little bit of recap, um, when we do f of x is equal to b to the power of x, we have to say that b has to be greater than 1, or greater than 0, but b can't equal 1. As in, b can equal like a fraction, or b can equal like a big number as well, as long as b does not equal to 1. And that's because if b equals to 1, 1 to the power of 2 is equal to 1, and 1 to the power of like 10 is still 1. If no matter if I change this, it'll still equal to 1. And that's why b cannot equal to 1. It wouldn't make any sense. And today we're going to be talking about the transformations. And the transformations are very similar to our old notes. So let me try to find a old transformation notes. No, this is solving. Okay, this one's pretty good. Here we go. So just like in transformations of square roots, or even like absolute value and stuff like that, we talked about the vertical transition, which is up and down, left and right. We talked about reflecting, we talked about vertical stretch and compression. These are things that we're going to be talking about also for exponential functions. So let's just talk about this one right here. F of x is equal to 2 to the power of x is graphed to the right. Add the following functions to the grid. So they want us to do, they want us to shade in or graph f of x and the second f of x. This should actually, I'm going to make this g of x real quick. So that means if it's outside of the x's, it's going to be going up 1, and this is going to be going down 3. I guess I should write this in a different color. I'll write this green. So you see how my y-intercept for my black line is 2 to the power of x? That means this right here has to be my green line, or my f of x. And I'll just graph all these. And my asymptote looks like this, or my asymptotic behavior. And the reason how I got this, or like the way that I got this, is because everything in my graph just moved up 1 unit. Nothing changed about the slope, nothing changed about like anything else besides the fact that everything moved up 1 unit. And I can really just plug in a number for x. Let's say if I plug in 2 for x. So it'd be 2 to the power of 2 plus 1, that's equal to 4 plus 1, that's equal to 5. And that's where I got this point right here. I guess I'll make this yellow. So I got this point right here, because this is right here is 5. So it'd be 2 comma 5. So everything just got moved up 1. So in that same sense, if the number, or if the operation is outside of the x, or outside of, in this case, this parentheses right here, imaginary parentheses, it would be going up or down. So this is down 3. So if it's at 0, 1 for my original, 1, 2, 3. This would be my new y-intercept. And really the graph would look like this. And I didn't draw this perfectly, and that's perfectly fine because... Oh, actually, I should draw this better. Like this. There you go, that's better. And I can say like the asymptote for this one, what would that be? probably be y equals -3. And I got that because my asymptote is originally 0, as you can tell from this black line that's on the paper. I just moved it down 3 units. Okay, now let's look at this graph. 1/3 to the power of x. So you see how this operation right here, these operations are talking about going left or right. Very similar to like the square root of x minus 3 plus 1. It would be very similar to this part. The operation is happening inside of the rule of x. So this would be like the square root. And you also know that x minus 3 plus 1, if I square this, this would still be moving left to right. Same thing with absolute value. This is inside the rule of x, because the operation of x is going on before I do this or after I do this operation. So this is talking about left and right, and we always think opposite for the inside. So it says -2, but it's really going to the right 2, and this one's going to the left 2. So always think opposite. So let's see, if I make this green and I make this one blue, I'll be going to the right 2 for this one. So you see how it's right here, 1, 2. My new point will be right here. And this point right here, this is 2, 1. And I'll just draw it the same way. Oh, that's not good. Looks like this. Oh wait. Drawing it incorrectly. There we go. The blue one is going to the left 2, so 1, 2 is right here. And we're still gonna make that same movement. Oh. Nice. And since I didn't move it up or down, the asymptotes for both of these are still going to be y equals 0. Because I didn't move my asymptote, or I didn't move my graph up or down. Moving it to the left and to the right doesn't change the asymptote, because the asymptote is a left to right line. So in summary, vertical translations was the first one. If D, which is the outside right here, this D, is greater than 0, we move up. We move upwards. And if D is less than 0, like a negative number, it would move downwards. If C is greater than 0, but look at this equation right here. C is less than, or it's technically negative C, but we always think opposite. So if C is greater than 0, we're going to actually go to the right, because what happens is because B to the power of x minus 4, we move 4 units to the right. Even though this would be my C, or the variable for C, right? It still comes out to be x minus 4 in the end. So if C is greater or less than 0, it would move it to the left. Because if I do b to the power of x plus 4, or x minus -4, it would move it to the left 4 units. So vertical stretch, vertical compression, and reflection, it's the same rules. And I'm gonna actually give you guys the time to do this. So I'm gonna pause the video here. Let's see. I'm gonna try. Nah, I'm not gonna try anything. Hopefully I see this. If not, you get lucky. Oh, wait, hold on. Okay. So try this out just by using Desmos and graphing it yourself. Okay. So G of X I'll use black. This actually makes your y-intercept come like here. 1, 4. And -1, 1, like this. H of X is the same thing, but it's just reflected over the x-axis. So it looks like this. G of X, which I'll color with a green. 1, 1. Continue like so. And R of X, which will be my red graph. Actually the same thing, but reflected. So I'm gonna do that. So very generic. Even though I didn't color the graph correctly, or land all the points, at least I identified like the key points, which are these right here. And the y equals 0 is still the asymptote because I did not move the graph up or down. I didn't even move it left or right. I just made the slope greater. So here comes the next thing right here. Like a little reminder, exponential functions with base e have the same transformation rules as the other exponential rules. Ooh. Actually, before this, I want to talk about vertical stretch is number greater than 0. I guess I should use the same variable. We'll use a. When a is greater than 0. Ooh, greater than 1. And that's these numbers right here. Vertical compression is whenever your A is between your A is between 1 and 0. And that's these right here. But what about the negative sign? The negative sign is actually the reflection of x-axis. And if I color this one last time, -a, that's when this is negative right here, and that's negative. And that's how you know, like the blue graph and the red graph, that's why it flipped over the x-axis to become upside down. So reflecting over the x-axis really just makes it upside down. So exponential is really the same when you use base e, because we know that e is really similar to like 2.7, so it's just a regular number. So look at this problem right here. This b and this e is really just replaced, but instead of b, it's just e. And e, as I told you, e is 2.7-ish. So really the rules are still the same. So just know that this box right here is really the same thing as what I just talked about. So if a is greater than 1, it's a vertical stretch. If it's between 1 and 0, like a fraction, it's a vertical compression. And if a is a negative number, if a is negative, what happens? Let me put a question for the Edpuzzle here at 1620. And this reflects x-axis. Nice. So here's some practice problems. I'm not going to do all of them because I don't want the video to take too long. I'm going to let you guys practice as well. So let's try this one, a very simple one. I'll do number 1, I'll do number 3. So example 1 is saying that e to the power of x plus 2. What's going on? As in, list out the transformations and attributes. So we're using the same thing that we learned last class and this class. Well, I know I have this plus 2 right here. And it's not with the x, right? This, if I wanted to solve for y, then I would subtract 2 first, right? Y minus 2 is, well, I want to solve for y. But you know what I mean. I would move that 2 over if I wanted to. So this is an outside thing. So I know that my transformation is down 2 and nothing else. This is my answer. So if I graph this on Desmos, even though you shouldn't be using Desmos, let's just give an example. E to the power of x plus 2. The graph looks like this. And really, the graph just shifts up. So my domain, because I shifted up and down, doesn't change my domain. So this is all real numbers, which is negative infinity to infinity. But my range does change though. And the reason why is because my range is talking about up and down. So so what happens is that I'm going to make my range adjusted to the y, or this addition part right here, the transformation. So it becomes 2 comma infinity. And the reason why I do this parentheses here is because I'm excluding this, because my asymptote is y equals 2. 2 is not part of my graph. And the last one, y-intercept, really is told in my Desmos, but what happens is that you know that the y-intercept is 0, 1, and then you add 2 to this value right here, this value, so it becomes 0, 3. And that makes sense too, which is also recorded by Desmos, but very simple here. So let me give you guys some time to do example 2 by yourself, which the time is right now 1934. Okay, sorry about that. Alright, so example 2, I'm just going to tell you the answers just so that you can check your work. Here we go. This is always all real numbers. The range since I didn't move it up or down, it's still going to be y is greater than 0, or you can write it as 0 comma infinity. The asymptote is still y equals 0, and the y-intercept is some weird number, and that's perfectly fine. And the reason why it's a weird number is because it shifted to the right. Just let the calculator do the work from there. And really the way that you can do this is by plugging in 0 for y. So y is 0 is equal to e to the power of x minus 4. And you would solve for x there, or solve for x here, but you haven't learned that yet, so I just assume that you will use Desmos for this. Let's try this another example. Example 3. So lots of things are happening here. 1, 2, 3 things are happening. So it reflects. I guess I'm gonna erase all these. And then reflects x-axis, which is this. It shifts to the right 11 units. Different color here. And it goes up 1 unit. Notice that this 10 does not contribute towards the transformations because this is 10 is equal to b, and b is part of my question, as in it's part of like the parent function. I just chose a random number when I wrote this problem, and 10 will not be part of your transformations during your test. So domain, always going to be all real numbers for this graph. My range though, I went up 1 unit. So if my range is usually 0 to infinity with a parentheses, if I go up 1 unit, I should really just be going up 1 unit from a minimum, and in my maximum, or the maximum potential of my graph is infinity. Because in my graph, it's gonna look something like this. Something like that. The asymptote, once again, if my asymptote went to y equals 2 on my question 1, or y equals -2, sorry. Wait, did I go down 2? Whoops. So let's go up 2. If I go up 2 and my asymptote became 2, really this transformation is told right here. And also, since I don't have anything here, anything here being added or subtracted, that's why my y became 0. So this +1 really tells me that my my asymptote is going to be y equals 1. And the last thing, my y-intercept, if I plug in y for 0 and I try to type it into the calculator by doing algebra whatever, I get 0, 1. And if I just type this into Desmos as well, which I can probably do right here, -10 f of x is equal to -10 to the power of x minus 11 plus 1. I can see that my y-intercept is still 0, 1. So try out number 4. Tell me the biggest takeaway of today is being able to do this part right here where you list out the transformations. So let me give you a little hint. You should have what the heck? What happened to all my colors? Oh, here we go. You should have 1, 2, 3 transformations. So in the Edpuzzle, what are the 3 transformations that happen in example 4? It's at 2450. Okay. it went to the left 3, and went up 12, and it's a vertical compression actually by 2/3. And the reason why it's a vertical compression is because 2/3 is less than 1, or 1 is greater than 2/3. Domain, negative infinity to infinity. Range, y, or you can say y is greater than 12, but I'm gonna write it like algebra 2 way, which is this. I don't like this song. Okay. My y asymptote. See this right here? You see how this is also part of my asymptote? This 2 is part of this asymptote. This 0 is part of this asymptote right here. So this this range is part of my asymptote, which is y equals 12. Okay, and then last thing, y-intercept. I can just use Desmos for this part. 2/3 times 2 to the power of x plus 3 plus 12. My y-intercept is right here, 7.33. So 0, 17.33. Repeating. Alright, well that's pretty much it. You should have a practice already on Canvas, so make sure to do that as well, and I'll check you guys next time. Deuces.